Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to explain why ionic compounds can conduct electricity when molten or dissolved in water. You should then be able to describe the reactions taking place at the positive and negative electrodes during electrolysis. And finally, you should be able to describe the reactions as either reduction or oxidation. That's for higher tier students only. Now, electrolysis can seem like quite a tricky topic, so I'm going to split this over several videos. I should point out it's not as tricky as it first appears. In this video, we'll explore the general ideas behind electrolysis, and in later videos, we're going to look at some specific examples which you need to learn. We're going to start by recapping ionic compounds. This is the ionic compound lead bromide. This is formed when lead reacts with bromine. When lead bromide forms, a lead atom loses 2 electrons like this, forming the lead ion Pb2+. These 2 electrons then pass on to 2 bromine atoms, forming 2 bromide ions Br- like this. Now we formed our ionic compound PbBr2. So as you can see, lead bromide contains 2 different ions, the lead ion Pb2+ and the bromide ion Br-. So what happens when we carry out electrolysis on ionic compounds such as lead bromide? Let's start by looking at some key facts about electrolysis. Here's the first key fact. Solid ionic compounds cannot conduct electricity, and that's because the ions are locked in place. They're not free to move. I'm showing you the structure of a solid ionic compound here. This is lead bromide, which we saw before, but the idea applies to all ionic compounds. As you can see, the ions are locked in a regular pattern. They're held in place by strong electrostatic forces of attraction, so the ions are not free to move. However, when an ionic compound is melted or dissolved in water, the forces of attraction are broken and the ions are free to move. Because the ions can now move, these liquids and solutions can now conduct electricity, and scientists call these liquids or solutions electrolytes. So we're going to look now at what happens when we carry out electrolysis on a molten ionic compound such as lead bromide. Remember that the word molten means melted. So lead bromide contains 2 ions, the positive lead ion Pb2+ and the negative bromide ion Br-. In electrolysis, we've got 2 electrodes. These are made of a conducting material such as graphite or a metal. The negative electrode is called the cathode. That's attached to the negative terminal of a power pack. Think of the cathode as being covered with electrons which are coming from the power pack. The positive electrode is called the anode. That's connected to the positive terminal of the power pack. Think of the anode as having a lack of electrons. Here's our molten lead bromide. We can see the positive lead ions here, and we can see the negative bromide ions here. The positive lead ions are attracted to the negative electrode, and that's because opposite charges attract. The lead ions now gain 2 electrons to form lead atoms. Because the lead ions are gaining electrons, that's an example of a reduction reaction. The negative bromide ions are attracted to the positive electrode. Here they lose 1 electron to form bromine atoms. Because the bromide ions are losing an electron, that's an example of an oxidation reaction. Now I should point out that bromine atoms pair to form a bromine molecule, so we usually show the reaction like this. In the next video, we're going to look at how we can use electrolysis to extract reactive metals such as aluminium. Remember, you'll find plenty of questions on electrolysis in my revision workbook, and you can get that by clicking on the link above. Okay, so hopefully now you should be able to explain why ionic compounds can conduct electricity when molten or dissolved in water. You should then be able to describe the reactions taking place at the positive and negative electrodes during electrolysis. And finally, you should be able to describe the reactions as either reduction or oxidation. And that's for higher tier students only.